All right, so here is a mini lesson on adding and subtracting fractions. We're going to group these together just because they're very, very similar in what they do and how to kind of go about solving those. So, just so we have this. Okay, so first thing that we're going to start with is just kind of what a fraction is, just as like a kind of basis. So it is going to have some kind of numerator, which is going to be that number in the top, and then your denominator, which is in the bottom. Now, those numbers kind of commingle with each other when we're adding and subtracting, except for the fact that our bottom number, our denominators, whatever winds up being down here, has to be the same in both fractions in order for it to work. The top number does not matter. We can have it be kind of whatever we want up there, and then that is what gets manipulated with the other numerator of our other fraction. So just to kind of start giving you some examples here. If I had half plus 3/4. Okay, right now I cannot actually add those together because the bottom, the denominator, is not the same in both of my fractions. In order to kind of alleviate that or to adjust that, we're going to have to manipulate one of them by multiplying it by this fancy form of the number 1. Because when you multiply anything by the number 1, it doesn't actually change it. So noticing that 2 and 4 are related, if I double this fraction or multiply it by 2, so that is exactly what I'm going to do. I'm going to multiply this side by 2/2. Now, when I do this, 2 divided by 2 is 1. However, it's changing our fraction ever so slightly here. So when we multiply our tops together. So I'll have 2 times 1, which is 2, and 2 times 2, which is 4, plus now 3/4. Once my denominators are actually the same, then I'm going to go through and the bottom stays the same. Denominator does not change. I'm just going to wind up adding the top part, the numerator of my fraction together. So 2 plus 3, which gives me 5. Okay, now you could convert that into a mixed number from an improper fraction, but we're not going to be picky on that here. Okay. So here's another example. Let's do 3/5 plus 4/7. Okay, now this one, and again, you kind of heard me, my brain turning, the wheels turning when I was creating this one. I wanted to find something where the denominators are not visibly related, like that 2 and the 4 were. Like if you see the number 2 and the number 4, we should automatically start thinking like, hey, I know that there's a relationship between those. However, if we look at something like this, where I have a 5 on the bottom and a 7, there's not something that I can only do to one of those fractions in order to get them to have the same denominator. I'm actually going to have to manipulate both in this case. So I'm going to multiply this fraction by the denominator of the other side in that same fancy form of 1. So I'm going to get rid of that circle. So 7 times 3 gives me 21, and 7 times 5 gives me 35. Then I'm going to go through and I am going to do the same thing on this side, except I'm going to multiply this one by the denominator of the opposite side in, again, that fancy form of 1. 4 times 5 is 20, and 7 times 5 is 35. Now, that is why we multiplied by the opposite denominators to get those to change, because now look at our denominators of what we have in the purple and pink fractions. They are both a 35. So now I can actually go through, the bottom stays the same, and then I just add the top. So 21 plus 20 is 41. And again, you can adjust those answers however necessary, but subtraction is going to be the exact same thing. So if I were to, let's actually redo this problem just using subtraction so you can kind of see that. Okay, 3/5 minus 4/7. Again, I would take that same route to get to 21 over 35 minus 20 over 35, where I multiplied this side by that 7 over 7 and this side by that 5 over 5. Okay, so again, the only difference here is going to be that subtraction in the middle. My denominator still stays the same at 35, but now this time I'm going to do 21 minus 20, which is just 1. Okay, so adding and subtracting, I would argue, is a little bit harder than multiplication and division, which you will see in a different mini lesson video, but hopefully that this helps.